Alright, so today we're going to learn how to balance redox reactions by using the half reaction method. What is a half reaction? A half reaction is a chemical reaction that shows only oxidation or reduction. Oxidation is a process in which a substance loses electrons. Reduction is a process in which a substance gains electrons. Remember, when balancing, you always balance according to mass and charge. And especially with redox reactions, you have to identify whether the reaction is taking place in a basic or acidic solution. So let's practice. In an acidic solution, you have some copper and some nitrate ions, yielding copper 2 plus ions and NO2. First, identify your reduction and your oxidation reaction. We see that the copper going to the copper 2 ion is an oxidation because it's losing 2 electrons, which means the other one is reduction. For this one, you can simply just add 2 electrons to one side because it's already balanced according to mass. And then when you add the 2 electrons, it's balanced according to mass and charge. This one, you have to first balance anything that isn't oxygen or hydrogen. So we see that the nitrogens are already balanced, so we can move on. Oxygens. When balancing oxygens, you have to add water molecules to the side that needs more oxygens. So for example, NO3 1 minus yields NO2. Well, you're missing an oxygen, so you have to add a water molecule here. Now we have to balance out the hydrogens. To do this, you add hydrogen ions. Not hydrogen gas, but hydrogen ions. So you have 2 hydrogen over here, so you need 2 hydrogen ions over here. But if we look, we have an overall charge of 1 plus on this side and an overall charge of 0 plus. So to account for this, you have to add 1 electron to this side. Okay, now that we have our 2 half reactions and they're balanced, now we need to add them together. Before that, we need to make sure that the number of electrons exchanged in each reaction is the same. Here we have 2 electrons exchanged, but here we only have 1 electron. So we have to multiply this entire reaction by 2. So when we do that and then add them together, we get this big old reaction. 2 electrons plus 4 hydrogen ions plus 2 NO3 1 minus plus copper yields copper 2 plus ion plus 2 electrons plus 2 NO2 plus 2 H2O. So now we have this, we can cancel out the 2 electrons, and that's it. So that gives us our final equation. 4H plus 2 NO3 1 minus plus copper yields copper 2 plus NO2 NO2 plus 2 H2O. Let's make sure that we've got this. So we look at the overall charge. We have an overall charge of 2 plus on this side. Look at the charge on this side, overall 2 plus. So that's good. We have 4 hydrogens here, and 1, 2, 3, 4 hydrogens here. We have 2 nitrogens, again 2 nitrogens, 6 oxygens, there's 4 and there's 2 more, so 6, and then finally 1 copper on each side. Now we're going to do a basic solution. Basic solutions are pretty much exactly the same as acidic solutions, except for one small step at the end, which I'll get to later. So, let's start with our net ionic reaction. CN1 minus plus MnO4 1 minus equals CNO 1 minus plus a manganate. So, again, identify your oxidation and reduction. So, on this side, we have CN1 minus goes to CNO 1 minus, and that's our oxidation. Because this ion is gaining an oxygen, so it's an oxidant. Which means MnO4 1 minus going to MnO2 is our reduction. So let's balance our oxidation. Again, like we said before, to balance out oxygens, we add water molecules to the opposite side. So we add 1. And then now we have 2 hydrogens, add 2 more hydrogen ions on the other side. Now we look at overall charge. We have a 1 minus over here, but a 1 plus over here. So you need to add 2 electrons to this side, and you get that. Again, for the reduction reaction, you have MnO4 minus to MnO2, so you need 2 water molecules on this side. So you get this, and now you see that you have 4 hydrogens, so you have to add 4 hydrogen ions on this side, giving you this equation. Then you look at the charge, and you have an overall of +3, and no overall charge here, +0. So you add 3 electrons to this side to account for that. So pretty much it's been the same process. Now we look at the electrons transferred in each one. This one has 2 electrons transferred, but this one has 3. So we have to multiply this equation by 2 and the top equation by 3 to get the same number of electrons transferred. When we do this, we get this. We get 3 waters plus 3 CN1 minus plus 6 electrons plus 8 hydrogen ions plus 2 MnO4 minus yields 4 waters plus 3 CNO1 minus plus 6 electrons plus 6 hydrogen ions plus 2 MnO2. Again, like before, we cancel out everything that we don't need. So the electrons will cancel out, 6 hydrogen ions cancel out, so we're left with 2 in the reactant side, and 3 waters cancel out, which will leave us with 1 on the product side. So 3 CN1 minus plus 2H plus 2 MnO4 minus yields 3 CNO1 minus plus 2 MnO2 plus H2O. This would be great if we were just doing acidic solution. But now to account for the basic solution, we have to add hydroxide ions on either side of the equation to balance out any hydrogen ions. So we have to add 2 hydroxide ions on either side. And when you do that, you'll get 2 water molecules and 2 hydroxides. So you cancel out this water molecule and one of them on the other side to get your final reaction. 3 CN1 minus plus H2O plus 2 MnO4 minus yields 3 CNO1 minus plus 2 MnO2 plus 2 hydroxides.